All right, so we're going to move on to the next objective. So we were able to write the equation of a line with giving a slope and a y-intercept with a slope and a point. Now we're doing 2 points. So 2 points isn't that much harder. It's just one little step in there. So we're still going to end up using our point slope form. The problem is we don't have a slope yet. So we do have a pair of points though. So we'll just label these x1, y1, and x2, y2. So from here, we're just going to use our slope formula and figure out what m is going to be. So once again, always when you're working on anything of math, think about how do I go back to something I know how to use? I know how to use this formula, and I know to use that formula requires me to have slope. So I just try to go back, is there a way to get slope? Yes, there is. So we're always trying to work our way backwards to something easier to help us solve a problem. All right, sorry, there's people walking outside. So our y2 is going to be -4 minus y1, which is 2, x2, which is -6, minus x1, which is 2. So we're going to put the -6 over -8. This is a slope of going to be 3/4. Just double checking that. That worked right, huh? Yep. Okay. So from here, it actually doesn't matter which pair of points I use. But I usually say if you're not sure, just pick the ones you just labeled as x1, y1. Then you don't have to relabel anything. But I will show you that it doesn't matter which pair of points I have. We have a slope. I'm going to use this, and I'm going to tell us what the equation of the line is. So now we can use that equation. So we have y minus y1, which we said is 2. My slope, I said, is 3/4. And then I'm going to have x minus x1, which is 2 as well. So we'll just solve for y. So 3/4 times x is 3/4 x. 3/4 times -2 is going to be -6/4. So they don't always come out nice and pretty. I think I got too many negatives in there. Just a second. Let me go fix something. I made a little mistake. So we had -2 times 3/4, -6/4, or we can reduce that to 3/2. So if you add the 2 to the other side, we're going to have -3/2 plus 2. So just as a quick reminder up here for adding fractions, we want to turn 2 into a fraction with 2 on the bottom. So what we can do is we can rewrite 2 as 4/2 because that's still just 2. Now we have the same denominator and we can add those together. So y is going to be 3/4 x minus 1/2. My mistake, plus 1/2. Okay. So if you want to, you can go back and take this point as a checkpoint. So we'll just replace that x with a -6. So I actually did this on my calculator, but if you put that in there, you are going to find that y is -4. So that's another way to check this, is once you get it with one point, check to make sure that the other point is true. Because this is a line that's supposed to pass through both points, therefore it should work for both points. Okay, and then I promised to do this the other way. So let's say instead of using 2, 2 as my x1, y1, I use -6, -4. It's just going to quickly show us what would happen. So we would have y minus y1, so y minus -4, equals, my slope is still 3/4. I have x minus my x1's at -6, so minus -6. So initially looks like you're not getting the same equation, but let me solve for y. So if we multiply this, we get 3/4 x, 3/4 times 6. So you multiply the 6 to the top, 6 times 3 is going to be 18/4. 18/4, that can be reduced to 9/2. Now I'm going to subtract that 4 from both sides, so I have 3/4 x plus 9/2 minus 4. So we just need to change the 4 so it has a denominator of 2. So I can change that to 8/2. And if I do that, so 9/2 minus 8/2 leaves me with 1/2. So as we see, it doesn't matter which pair of points you pick, your point slope forms will be different, but your slope intercept form, your y equals mx plus b, will end up looking the same. So they're all equivalent equations. Actually, let's make that point here, that every version I have of this, these are all considered what we're going to call equivalent equations, meaning that they have the same solutions to all of them. In the original form that I had on the last slide, all of those are still equivalent equations to this. All right, so if you take a minute, pause and attempt this on your own. So you're going to do number 4, 5, and 6 on your worksheet. Okay, so I'm not going to do this 2 times each point. We'll just pick one. So we'll find the equation of this line. So like I said, we need to pick a pair of points to be our x1, y1, a pair to be our x2, y2. The first thing we're going to do is we're going to look for slope. So we know slope is just going to be your, like I said, y2 minus y1, x2 minus x1. Let's fix that x1, so it's a 1. So we will have 2 minus a -4 over 5 minus 3. So that is going to leave me with 2 plus 4. And then we're going to have 5 minus 3, so 2 on the bottom. So we have 6/2. So we're getting a slope of 3. Yep. Okay. So now y minus y1 equals m times x minus x1. Y minus y1. So like I said, we already labeled pair of points. We'll just use those. So our y1 is going to be the -4. My slope is 3. Then I'm going to have x minus x1, and x1 is going to be also 3. We're going to subtract the 3. Then we're going to have y plus 4 equals 3x minus 3 times 3, which is 9. Subtract the 4. Y equals 3x minus 13. So from here, like I said, a good idea is to check with the other point. So we're going to check with the 5, 2. So I'm going to leave the y the same. I'm just going to replace the x with the 5, and we're going to see if we get a 2 back. So we get 15 minus 3, which is going to equal to 2. So we get y is equal to 2 back again. So it is correct. So find the equation of a line containing the points 5, minus 2, and 1, 1. So we'll make, we'll make this x1, y1, x2, y2. Sorry, that was just my brain just dying there. If we want slope, we're going to do this the way we did it before. So take those points. So remember, y has to be on top. So 1 on top and then 1 on bottom. And then we'll take these points. These are going to be subtracted. This one goes on top. And then the 5 has to go directly underneath it. So remember, keep those pairs of points together. So we're going to end up with 1 minus minus 2. So that is going to be 3. And 1 minus 5, minus 4. Then we're going to have y minus my y1, which we said is the negative 2, equal to my slope, which we just found is to be minus 3 over 4. And then we are going to have x minus x1, and x1 we said over here was 5. So y minus minus 2, y plus 2. If we distribute this, we get minus 3/4 x times that 5. So the 3 times the 5, going to be 15, and then we keep the 4 on the bottom. Negative times negative, so this is a positive. Now we just subtract the 2 from both sides. So remember, we're subtracting a 2, but I want to make sure that it has a denominator 4, so I'm just going to rewrite it as 8 over 4. So that's still my negative 2, just rewriting it. So if we have 15/4 minus 8/4, that's going to leave me with 5, 6, 7, 7/4. Okay. Now to check it, we're going to check with our remaining point 1, 1. So y equals negative 3/4. We'll replace x with 1. And then if we get the right answer, y should be 1. So minus 3/4 plus 7/4 will leave me with 4/4, which is equal to 1. So yes, this is correct. All right. So we'll see, but hopefully you guys notice that these are intercepts. So this would be your x-intercept. And this one is your y-intercept. But once again, x1, y1. And then I'll show you how you could have cheated this, unless you already figured it out. If we're looking for slope, y2 is 1, y1 is 0, x2 is 0, x1 is 5. Or think those points are stacking 1 over 0, 0 over 5. Either way, we're going to get 1 over negative 5. So if we do y minus my y1, so my y1 was 0, my slope was a negative 1/5, and then I have x minus x1, which we said was 5. We get y is equal to negative 5/5 x. So negative 1/2 times, or negative 1/5 times 5 will leave me with a positive 1. Or you may have noticed this. We found the slope. We found the slope. Let me spell slope correctly. So we know slope, and we know this is a y-intercept. So we know that b would be 1. So either way would have been correct. It's just, once you get kind of used to this, you can kind of find quick ways to solve these problems. You don't always have to, when you're provided with 2 points, use point slope form. In this case, I realize that one of these is a y-intercept, and that can save myself a lot of work.